Hello everybody, let's quickly prove this identity regarding inverse circular functions. We're given that x is not equal to 0 and is between -1 and 1, okay? And we need to prove that tan inverse of this quantity inside the brackets is equal to pi over 4 plus half cos inverse of x squared. Now this is not a strange question, but it's a textbook question. It's either stated and proved as a theorem in textbooks or it's in the exercises. And what most of the textbooks and most of the teachers for that matter do is that they make students memorize that all you have to do in this particular problem is that you need to remember we need to put x squared is equal to cos twice theta, simplify this expression, okay, simplify this expression and get the identity and get the value of this expression to be something like I guess this is it, this expression to be this thing, and then we get pi by 4 plus theta is equal to tan inverse of whatever that is inside the brackets, and theta means from this relation half cos inverse of x squared, okay? Alright, that's not completely wrong, but most of the books, they do not, at least the ones I've seen, they do not specify any conditions on theta, which is not correct technically. So that's why I wanted to discuss this question. Now, you don't have to memorize this, okay? You don't have to memorize this. Yeah, this is what we're going to do. We're going to put x squared is equal to cos twice theta, but you don't have to memorize this, okay? You don't have to memorize this. Now, if we don't have to memorize this, then how are we going to know that that's something we'll have to use in this while proving this identity? How are we going to know that? Just look at the given identity, okay? This can be simplified, okay, under certain conditions, but this looks pretty much weird, right? Intuitively, this looks pretty much weird. Now, let's suppose that this is theta, okay? Let's suppose that this is theta. So, let theta is equal to half cos inverse of x squared. Now, cos inverse of x squared. Now, x squared is positive. X squared is positive. Not even 0 because x is not equal to 0. Okay, x squared is positive. Now, then let's look at the possible values of cos inverse of x squared. Now, since we're dealing with inverse circular functions, we need to work with only the principal domain of cosine function, okay? So, principal domain for cosine function is the closed interval 0 to pi, okay? Now, if I can draw it correctly, this is the cosine function under the restricted domain. Okay, here's 1 and here's, at this point is -1. Okay, this is y equals cosine of x. Y equals to cosine of x. Alright, now since x squared is greater than 0, cos inverse of x, anything greater than 0, okay, greater than 0, must be between 0 and pi by 2, right? The inverse of any value greater than 0, must be between 0 and pi by 2. So cos inverse of x squared is non-negative and is strictly less than pi over 2. This is what we get. Okay, this is what we get. Alright, because x squared is greater than 0. And this is what we get. Now, if that's the case, then half of this will be between 0 and pi by 4, like this. Okay? Half of this thing will be between 0 and pi by 4. So, we'll make use of this thing. Now and this is theta, right? Basically. We suppose this to be theta, so what we have obtained is we'll make use of this thing. Okay, now let's look at this equation. This means twice theta is equal to cos inverse of x squared, and by definition of inverse circular functions, we'll get x squared is equal to cos of twice theta. Right? Yeah. So, so this is the thing which gives x squared is equal to cos twice theta. Okay, now let's proceed with simplifying this expression. 1 plus x squared plus 1 minus x squared over 1 plus x squared minus 1 minus x squared. Okay, now x squared is cos twice theta, so it is 1 plus cos twice theta plus 1 minus cos twice theta over square root of 1 plus cos twice theta minus 1 minus cos twice theta. Okay, now we know that 1 plus cos twice theta is equal to 2 cos square theta, and we also know that 1 minus cos twice theta is equal to 2 sine square theta. Okay, so this means the square root of 1 plus cos twice theta is equal to the square root of 2 times the square root of cos squared theta, which is equal to square root of the absolute value of cos theta. Okay, similarly, this is 1 plus cos twice theta is equal to square root of 2 square root of sine squared theta, which is equal to square root of 2 and absolute value of sine theta. Okay, now let's look at this. Theta is between 0 and pi by 4. Okay, theta is between 0 and pi by 4. So for the cosine of theta, let's see, this is cosine of theta. Theta is between here, right? For these values, the cosine of these values is always non-negative. So for these values of theta, cosine is non-negative, so we can omit the absolute value. Absolute value is a modulus sign. Okay, and if we look at the sine curve, sine curve would look something like this. Okay. Sine curve will look something like this. I'm not drawing this in the principal domain. Okay. It's pi. This is 2 pi. This is pi over 2. And this is 1. So pi over 4 is somewhere over here. So for these values of theta, for these values, okay, since theta is between these two values, the value of sine theta will also be positive, or at least non-negative. So we can omit the absolute value signs. Okay, so this is square root of 2 sine theta. Now let's use these in the identity. Let's use these in the identity. Let's continue from here. Okay, this thing right here is square root of 2 cosine theta plus this thing is equal to square root of 2 sine theta. Okay, and the denominator, same thing but minus. We can cancel these out easily so that we get 1 plus sine theta over cos theta over something like this if we factor out cos theta, and something like this if we factor out cos theta again. And we can factor out cos theta because cos theta is not 0. Okay, it's not 0. Cos theta, this is where theta belongs, so cos theta is not 0, it's positive. So we can cancel out cos theta, and sine over cos means tan, so this is 1 plus tan theta, 1 minus tan theta. Okay, all right, now we're basically done. So whatever we've obtained is that this thing right here is equal to 1 plus tan theta over 1 minus tan theta, right? Okay, now 1 is equal to tan of pi over 4, all right? 1 is equal to tan of pi over 4, so tan of pi over 4 plus tan of theta over 1 minus 1 times tan theta means tan pi over 4 tan theta. Okay, all right, now this tan A plus tan B is equal to tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. So this is equal to tan of A plus B. Okay, now let's look at this thing. Pi over 4 plus theta. Since theta is less than pi over 4, we get pi over 4 as it is plus theta is less than pi over 4, so pi over 4, which is equal to pi over 2. Now since theta is greater or equal to 0, we get pi over 4 is less than or equal to, oh sorry, this is equal to pi over 4. Now, the principal domain, tangent function, is the open interval minus pi over 2 to pi over 2, and since pi by 4 plus theta is a value between pi by 4 and pi by 2, is a value between, let's say this is pi by 4, is a value between this but not this, right? Pi by 2 is not included, is a value between pi by 4 inclusive and pi by 2 exclusive. So this is a value in the principal domain of tangent. Okay, this is a value in the principal domain of the tangent function, and just because of that reason we're allowed to write pi by 4 plus theta is equal to tan inverse of square root of 1 plus x squared minus, sorry, plus 1 minus x squared over square root of 1 plus x squared minus square root of 1 minus x squared. Okay, 1 minus x squared. So this is how we prove this identity. Now basically theta equals to half cos inverse of x squared, so this is pi by 4 plus half cos inverse of x squared. This is how we prove this identity. Okay, all right. Now let's look at another way in which we can obtain x squared is equal to cos of twice theta, with the same conditions being subjected to what do you call it, on theta. Okay, now we were given that x is not equal to 0, and this was something which was also given, so this will mean x squared is less than or equal to 1, but since x is not equal to 0, we'll have this inequality. So x squared is between 0 and 1, something like this. So if this is the graph of y equals to cos x, then x squared is somewhere over here. So to this x squared we can find some alpha, okay, some alpha which is equal to, which is such that cosine of alpha is equal to x squared. It's clearly indicated in this diagram. So we can find alpha between 0 and pi by 2. We can find alpha between 0 and pi by 2, and alpha is not equal to pi by 2 because x is not equal to 0. Okay, x is not equal to 0. X is not equal to 0. Okay, x is not equal to 0. So we can find something, we can find an alpha between so if alpha belongs to this interval, then alpha by 2 will belong to this interval, definitely, isn't it? Alpha by 2. And if we put alpha by 2 is equal to theta, then theta is between pi by 4, sorry, 0 and pi by 4, and cos alpha is equal to cos of twice theta. So in this way also we can obtain the required substitution, x squared is equal to cosine of twice theta. Okay, all right, thank you very much.